Hi all, today we are going to talk about scaling of instrument. When I say scaling of instrument, that means that if you have instrumentation in some plumbing, let us consider a pressure transmitter, which is rated for a pressure of P1 to P2 and whose signal varies from X1 to X2. Then if I say you that if you have X3 as a signal, this is VDC voltage, this is PSIG pressure. If you have X3 as a signal where X3 is a value between X1 and X2, then what will be the pressure at X3? In the industry, you always have instrumentation which varies their uh, signal from either 4 to 20 milliamps or 1 to 5 volts, like that. But how to scale that? That is what we are gonna see here. Please note that in this video we will only deal with linear instruments. So linear instruments are those instruments whose signal characteristic varies linearly from one point to other point, and this is process value. Now process value, in this case we are considering pressure transmitter, so it is pressure, but the same theory can be applied for all the linear flow, temperature, density measuring instruments. So the linear instruments has a characteristic something like this. If I take this example, so this says this will be x1, this will be x2, and at x1 the pressure would be p1, and at x2 the pressure would be p2. And from industrial standard, if I say that, let us say there is an instrument whose signal varies from 1 to 5 volts for a pressure of 0 to 30 psig. So in this graph you can also show that as this is 1 volts, this is 5 volts, and the pressure varies from 0 psig to 30 psig, and this distance is deliberately kept because if the instrument fail, it will not show you 1 volts, it will show you 0 volts, but that we will discuss later on. So currently we need to find out relationship between what is the relation between the signal x and the process variable p. We need to find a relation between x and p, so that if we know the x, we can find out p. So we know from mathematics that the equation of a straight line or of any linear equation is generally given by y is equals to mx plus c. In the world of instrumentation, this c is called offset, this m is called gain, this x is the signal, and this y is the process variable. In our case, this is called pressure. Now, if you want to find out the equation of this line, this would be y1 or p1 is equals to gain multiplied by x1 plus offset is c1, and the other is process 2 is, that is this point, is gain multiplied by x2 plus c2. If we solve this equation, you will get gain as p2 minus p1 by x2 minus x1. These are very simple linear equation in two variables where G and C, oh, the C will remain same. G and C are variable, and C will be P1 minus gain times X1 and P2 minus gain times X2. Now, if we closely look into this, P2 is basically the maximum process value, the maximum value of process value. So here we can also say what is the process max minus what is the process value minimum value. What is the minimum of the process value? What is the maximum of the process value? What is the max of the process value minus what is the minimum of the process value, divided by this X and X1, X2 are signals. So this is signal, like what is the signal max minus what is the signal min. And similarly for offset also, you can write this equation as process minimum minus gain times signal minimum, and this equation as process maximum minus gain time signal max. This is max. Now we'll take an example for this value. If we want to find out what is the gain and offset of a pressure transmitter, which varies his signal from 1 to 5 volts and whose process value or whose pressure varies from 0 to 30 psig, then we can find out the gain as what is the maximum process value, that is 30 minus 0. What is the maximum signal is 5, what is the minimum signal is 1, then it will become 30 by 4, which is 7.5 psig per VDC. And the offset, so there are two equations for offset. You can use either of them. I'll first go with the first one. What is the process minimum value? That is 0 minus what is the gain? 7.5. What is the signal minimum? This is multiplication here. What is the signal minimum? That is minus 1. Then the offset from first equation is also minus 1 psig. And what is the offset from second equation? If you find out, actually you need not to calculate both, but just for example I'm calculating it here, that it would be what is the max process is 30 minus gain 7.5 multiplied by maximum signal is 5. If you will calculate this, oh, this is 7.5 actually. If you will calculate this, 30 minus it will be 30 minus 5, 35. 34, 36, 37, 37.5. So you'll get again 7 minus 7.5 at as the offset Ig. So this is your gain. For this example, this is your offset. Now all you need to do is to put this gain and offset in this equation, and you will have your process variable as gain times m is the gain, that is 7.5 times the signal plus offset, which is minus 7.5, so it will be minus 7.5. Now this is the equation of your instrument. This you feed it to a microcontroller, to a PLC, anywhere, and now if you have a signal of, let us say, 3, so this equation will become, now if your voltage is 3 here and you want to find out what is the pressure here, this equation will become 3 multiplied by 7.5, so you'll get 22.5 minus 7.5, you'll get 0. 15.0 psig. So your process value variable for a pressure transmitter at 3 volts would be 15 psig. And if you want to check that what would happen if it is 1 volts, then this signal will become, for 1 volts, pressure of 1 volt, this 7.5 multiplied by 1 minus 7.5, you'll get 0, and process variable for 5 volts would be 7.5 multiplied by 5 minus 7.5, and you will get 30 psig. I hope you understood how to calculate, how to scale an instrument and how to calculate the gain and offset. Thanks.